It's kind of wild to think about what connects the plastic in your keyboard, the vanilla in your ice cream, and even the fats inside your own body. Believe it or not, it all comes down to one single family of chemical compounds, carbonyls. They're like these unsung heroes running the show in both giant factories and in nature itself. So let's dive in and explore the two main branches of this incredible family.
So think of this as our roadmap for today. We're going to head down two main roads. On one side, you've got aldehydes and ketones. These are the absolute powerhouses of industry and chemical manufacturing. And on the other side, we have carboxylic acids, which are the fundamental building blocks of the natural world. Let's kick things off on the industrial side of town.
All right, first stop on our tour, aldehydes and ketones. Seriously, think of these guys as the ultimate multi-tools in a chemist's toolbox. They are literally everywhere, doing all sorts of jobs that make our modern world possible.
And what's so cool about them is that they really play two main roles. Over on the left, you see them as solvents. Something like acetone, for example, is just amazing at dissolving things. That's why it's so critical for making paints, coatings, and adhesives. But then on the right, you see their other big job. They're the starting materials you use to build other, more complicated stuff. Let's zoom in on a really famous one, formaldehyde. You probably heard of it as formalin, right? That's what's used to preserve biological specimens. The classic frog in a jar from high school biology. But here's the crazy part. That exact same basic molecule is also an absolute beast at creating polymers. It's the backbone of things like bakelite, which was one of the very first synthetic plastics, and those super tough urea formaldehyde glues. And acetaldehyde? Oh man, this one is a perfect example of a chemical's starting block. Just look at it, sitting right there in the middle. From this one single molecule, chemists can go on to make a whole world of products. We're talking everything from acetic acid, which is basically vinegar, all the way to plastics, polymers, and even life-saving drugs. It's amazing, one simple molecule just branching out into countless different things.
But hey, it's not all about super strong glues and industrial chemicals. Aldehydes and ketones are also responsible for so many of the smells and tastes that we know and love. Take benzaldehyde, for instance. It gives off that lovely almond scent, so of course it's used in perfumes. And then you have vanillin. That's the compound that gives vanilla its unmistakable, delicious flavor. So from the glues holding our world together to the scent of a perfume, these guys do it all.
Okay, so that's one side of the family down. Now let's shift gears and follow that arrow over to the other side of the carbonyl landscape. We are now entering the world of carboxylic acids. And if aldehydes and ketones were the workhorses of industry, then you can think of carboxylic acids as the master architects of the natural world. Let's find out what makes them tick.
See, all their power, everything that makes them special, comes from this one very specific and kind of elegant little piece of chemical design.
And the secret, well, it's literally right there in the name. Carboxylic acids are all about a thing called the carboxyl group, and the name itself gives you the recipe. It's a mashup of a carbonyl group, that's the C double bonded to an O, and a hydroxyl group, the OH. You stick them together on the very same carbon atom, and boom, you get the carboxyl group, written as COOH. Every single carboxylic acid has this exact signature.
Okay, so once you have that basic COOH group, things split into two main camps, and it all depends on what's attached to it. If you've got a straight or a branched chain of carbons, chemists call that an alkyl group, then you get an aliphatic acid. But if what's attached is a stable, flat ring of atoms, an aryl group, it's called an aromatic carboxylic acid. It's really that simple. Think of it as a chain versus a ring.
So we've got the basic chemistry down, but where do you actually find these things? Well, this is where carboxylic acids really come alive. This is their home turf. You'll find a ton of these acids all throughout the natural world, but there's a special group of those aliphatic ones, the long chain guys, the ones with between 12 and 18 carbon atoms, and they get a special name, fatty acids. And yeah, just as the name suggests, they are the essential building blocks of natural fats. They're usually found attached to another molecule called glycerol. And you know what? Just like their industrial cousins, these carboxylic acids are fantastic starting points. You can see right here how they sit at the very heart of organic synthesis. They're the core ingredient you use to create a whole bunch of other vital biological and chemical compounds. Whew, okay, we have gone from factories to fatty acids. That was a lot. So let's just do a super quick recap of the biggest, most important ideas from our journey into the world of carbonyls.
So if you only remember a few things, make it these. First, the foundation for everything we talked about is that carbonyl group, the C double bonded to an O. Second, aldehydes and ketones are the industrial workhorses. Third, carboxylic acids have that unique carboxyl group, the carbonyl and hydroxyl combo. And finally, these acids are nature's go-to building blocks, especially when it comes to making fatty acids.
I mean, when you really stop and think about it, the story of the carbonyl group is just incredible. It's in factories creating the plastics that literally shape our modern lives, and it's also deep inside our own bodies, forming the very fats that give us energy. It's truly at the center of, well, everything. Which kind of leaves us with one big, fascinating question. What's next? What's going to be the next big role for these ultimate chemical building blocks?